Good day, students. Welcome to math.serve.com. In this clip, we're going to be going over 5 examples on directional limits at discontinuities. Don't forget to visit our website at math.serve.com for access to a wide variety of tutorials ranging from algebra to calculus. Alright, let's take a look at question number 1. We're to find a limit as x approaches -1 from the right of the floor of 2x minus 1. Okay? Alright, so let's go ahead and evaluate this limit. We're going to evaluate this by direct substitution. So we're going to have, we're going to plug in -1 from the right in here. So we're going to have the floor of 2 times -1 from the right minus 1. The floor of that expression, okay? So if you simplify, we're going to have the floor of 2 times -1 from the right is simply -2 from the right minus 1. I'm going to find the floor of that. And then when you combine these two together, you're going to have -3 from the right. Okay? So what is an example of -3 from the right? To help us visualize this, what this numerical value is, you can go ahead and sketch a number line. Okay, so if this is -3 on the number line, if you're approaching -3 from the right, you're approaching in this direction, and we're looking at numbers such as 2.9, 2.999, 2.9999. Okay, so this is approaching -3 from the right. Alright, so if we want to use a concrete example to represent this number, we can just say, oh, we're looking for the floor of -2.999. That is just an example. Okay, so what does the greatest integer function do? The greatest integer function rounds non-integers to the biggest integer that's smaller than that number. Okay, so what is the biggest integer that is smaller than -2.999? The greatest integer that is smaller than -2.999 is -3. Okay, so this is simply going to be -3. So that's the answer to this limit problem. Alright, let's take a look at question number 2. We want to find the limit as x approaches -1 from the right of -3 e to the 1 over x plus 1 over e to the 1 over x plus 1 plus 1 plus 2. Alright, so first thing we're going to do is we're going to try and simplify this expression. I'm going to multiply the numerator and the denominator by 1 over e to the 1 over x plus 1 so that I can have only one term that has 1 over e to the 1 over x plus 1. Okay, so let me go ahead and show you what I'm talking about. We have limit as x approaches -1 from the right of 3e to the 1 over x plus 1. That's negative over e to the 1 over x plus 1 plus 1. Okay, and then what I'm going to do is I'll multiply the numerator and the denominator by 1 over e to the 1 over x plus 1 on the numerator, and then the entire denominator by 1 over e to the 1 over x plus 1. Alright, and you don't want to forget this plus 2 that we have over there, so we're going to add the plus 2. And then we're taking the limit of this entire expression. Okay, so you might wonder, why am I doing this? If we evaluate this limit by direct substitution, we're going to have an indeterminate form here because of these two terms right here. Alright, so we have to condense it into one. Now if we simplify the numerator, what we're going to have some cancellation action happening here. This cancels with that. And then in the numerator, we're going to have, let's write the limit. We have the limit as x approaches -1 from the right of um, of -3. And then in the denominator, when you distribute 1 over e to the 1 over x plus 1 to this term right here, they cancel out to just 1. Cancels out to just 1. And then plus, when you distribute this term to the 1 right here, you're going to have 1 over e to the 1 over x plus 1. Okay? So we have that situation there. So the goal again was to reduce this. We have two terms with the e to the 1 over x plus 1. Now I have just only one term with that. So hopefully we can find the limit here without any complications. And then let's not forget the plus 2. All right. Okay, so what I'm going to do next is evaluate the one-sided limit. So I'll accomplish this by simply substitution. So I'm going to have -3 over 1 plus 1 over e to the 1 over, instead of x, I'll have -1 from the right plus 1. Okay? So I just plugged in -1 from the right into this x right here. And then we have plus 2. Let's simplify a little bit further. We're going to have -3 over 1 plus 1 over e. Now -1 from the right plus 1 is going to give us 0 from the right. So we'll have e to the 1 over 0 from the right. Okay? Plus 2. And then that gives us -3 over 1 plus 1. Now 1 over 0 from the right is the same thing as infinity. So we have 1 over e to the infinity plus 2. Alright, let's go ahead and simplify it a little bit more. So we're going to have -3 over 1 plus, now 1 over, e to the infinity is just infinity. So we have 1 over infinity plus 2. And that gives us -3 over 1 plus 1 over infinity, simply 0, plus 2. Okay, so that gives us -3 over 1 plus 2, and -3 plus 2, well, this is -3 plus 2, which is just simply -1. Alright, so there goes your limit right there. Now let's take a look at question 3. We have a piecewise defined function. We have to find the limit as x approaches -2 from the right of this function right here. So whenever I'm dealing with piecewise defined functions, I like to use number lines to give myself a visual as to what function is active on the direction that I'm approaching the limiting value by. Okay? So we're approaching -2. We're approaching -2 from the left side. Okay, so -2 from the left is this direction right here. This region right here is where x is less than 2, and then this half region right here, this interval, and then over here is where x is greater than 2. Okay, -2. Let's put a negative there. All right, so you have two functions right here. Function 1, the first function is active in this interval right here. See, it says x is less than or equal to 2. And then function 2 is active in this interval right here. So when you're approaching -2 from the left, the function you're going to be looking at is function 1, which is -x squared minus 2x minus 2. In this interval, we have 2x plus 1 active, but we don't care about this since we're approaching -2 from the right. This is what we are focusing on, okay? All right, so this limit, the limit as x approaches -2 from the left of the function, piecewise defined function, it's going to be the same thing as the limit as x approaches -2 from the left of -x squared minus 2x minus 2. Okay, to evaluate this, we're just going to use the method of direct substitution. Just plug in -2 into all the x's. So we have negative 2. The directionality is not relevant anymore since we have already isolated the function to be utilized. So negative x squared is going to be negative 2 squared minus 2 times negative 2 minus 2. Alright, so here we're just going to use order of operations to simplify this expression. So we have negative 2 squared is 4, so we have negative 4 plus 4 minus 2, and your limit is negative 2. Okay? Now let's take a look at question number 4. This involves an absolute value. So let's see. You notice this absolute value, we can simplify it a little bit more. So this is the limit as x approaches negative 2 from the left of, in the numerator I can factor out negative 5, right? So negative 5 times x plus 2. And then in the denominator I can factor out negative 1. So the absolute value of negative 1 times x plus 2. Alright? So we know the impact this absolute value bars will have on this argument right here is going to basically get rid of this negative sign right here. So we're going to have the limit as x approaches negative 2 from the left of negative 5 times x plus 2 divided by the absolute value of x plus 2. Okay? Now we are approaching this absolute value quantity from the left, and we know that absolute value can be replaced with the following expression, so we can write this as a limit as x approaches negative 2 from the left of negative 5 times x plus 2 divided by plus or minus x plus 2. So since we're approaching from the left, we're going to have the limit as x approaches negative 2 of negative 5 times x plus 2 over negative x plus 2. Now what just happened here? Well, this directionality negative right here basically involves us taking a negative part of the absolute value quantity, okay? So if we're coming from the right, we'll take positive x plus 2. If we're coming from the left, we'll take negative x plus 2, okay? So this plus or minus, this directionality tells us which sign to take. From the left, you take the minus. From the right, you take the plus, okay? So you notice I dropped the sign here because I already picked the negative piece of this expression right here, okay? Alright, so now we have that. You notice that we can simply cancel out this x plus 2 quantity. These two cancel out. So we'll have the limit as x approaches negative 2 of 5. Now this is a constant, is independent of where x goes to, so our final answer will be positive 5. Alright, let's take a look at the last example. It's kind of similar to question number 4. I felt that we should do another problem similar to that so that we can really understand the process of finding directional limits involving absolute value. So here we have the limit as x approaches negative 1 from the right of the absolute value of x plus 1 over x plus 1. So we don't need to make any simplifications here, so we just write this as the limit as x approaches negative 1 from the right. Now absolute value can be written as plus or minus x plus 1 over x plus 1. Now since we are approaching negative 1 from the right, are we going to take the positive or negative sign? Remember in the previous problem we're coming from the left, so we took the negative sign. Now that we're coming from the right, we're going to take the positive, okay? So we're going to be taking positive x plus 1 in the numerator. So the limit as x approaches negative 1 of x plus 1 over x plus 1. Notice I dropped the directionality because I just picked the positive piece of this numerator here. Now let's see what happens. X plus 1's divide out. You're left with 1. Now this limit becomes the limit as x approaches negative 1 of 1. Now positive 1 is independent of where x goes, so our final answer is 1. Alright, so we can go ahead and try out these practice problems and check your answers. Thanks so much for taking the time to watch this presentation. We really appreciate it. Feel free to subscribe to our channel for updates to other cool tutorials such as this. Do post a comment in the comment section to let us know what you think about this clip. We really appreciate it. More clips can be found on math.serve.com. Thanks again for watching and have a wonderful day.